Hi there. Our first lesson of this unit deals with extrema on an interval, primarily absolute maximums and absolute minimums. In later lessons we will look at relative maximums and relative minimums. And to start us off, we have to be able to identify critical numbers. Critical numbers will play a role in both this lesson and lessons to come. A critical number exists where f prime is equal to 0. So remembering f prime, our derivative, is the slope of a tangent line. So we're looking for locations on our graph of f where we could draw in a horizontal tangent line. F prime equals 0. In addition, critical numbers are also where f is not differentiable, as long as it's defined, meaning it can't be not differentiable because it's a discontinuity. But this would be a case of like a cusp. A cusp would be a critical number because it would potentially be a relative maximum or a relative minimum. And at that cusp, f would not be differentiable. So again, critical number f prime equals 0 or f is not differentiable. And so to find our critical numbers, we're going to take our initial function. In this case, I've got number 12 from your book, which our initial function is g of x equals x squared times the quantity of x squared minus 4. We're going to take that initial function, we're going to take its derivative and set the derivative equal to 0, because that's where a critical number is, f prime equals 0. If this were an absolute value, I also would potentially want to take into consideration cusps, right? But this is not an absolute value, so we're good to go. Okay, and so I have product rule occurring here. Another option, if you didn't want to do product rule, would be to distribute that x squared in. Okay, but I'm going to go ahead and do product rule. And so we've got 1 d2, derivative of x squared minus 4, is 2x, plus 2 d1, derivative of x squared, is 2x. Just cleaning this up a little bit, 2x times x squared is 2x cubed. Distributing in that 2x, we get 2x cubed minus 8x. And I notice this 2x cubed and 2x cubed can make 4x cubed. And remember, we aren't done until we factor, and you're going to see why in a very short bit here. I have a 4x I could pull out, which will leave me with x squared minus 2. Okay, so now that we're at that point, we've taken our derivative. At that point, we are going to go ahead and set this equal to 0. And now when you have two quantities being multiplied and they together equal 0, technically speaking, only one of them has to equal 0, right? 4x could equal 0, and it wouldn't matter what this quantity was. For all we care, it could be 2,689. 0 times 2,689 would still be 0, right? And then the reverse would be true as well. If the x squared minus 2 was 0, then it doesn't matter what the 4x is. When I multiply 0 to it, it's still going to be 0. Right, which allows us to take both of these separately and say, okay, what would x have to be for 4x to equal 0? And what would x have to be for x squared minus 2 to equal 0? Okay, well, in this first one, x would be 0. And in this second one, if I add 2 to the other side, I get x squared equals 2. And when I take the square root, I get plus or minus root 2. And so all three of these would be critical numbers. Okay. So using that same strategy here, or utilizing it within the context of a different one, we are going to be finding absolute extrema, locate absolute extrema. Now an absolute maximum on a given interval would be the highest point on that graph. It doesn't matter whether or not it's a relative maximum, and when I refer to a relative maximum, I mean a hill on the graph, right? If my graph looks like this right here, this is a relative maximum, that top point. An absolute maximum might be that relative maximum, but it doesn't have to be. It's just the highest point. Okay? Same with the absolute minimum. If we had a valley, right, it might be the same thing as that relative minimum down there, but it doesn't have to be. It just has to be with the absolute minimum the lowest point. So absolute maximum, the highest, absolute minimum, the lowest. And for finding those points, we're going to start with finding our critical numbers. And the reason we do that is because our relative maximums and relative minimums are critical numbers. And since that might be where my absolutes are, I need to know what those x's are, what those critical numbers are, so I can evaluate whether or not they're my absolute as well, or if they're just a relative. Okay? So I'm going to start like we just did on number 12 by taking the derivative. Derivative of x squared is 2x, derivative of 2x is 2, derivative of 4 is 0, and setting that equal to 0. So we get 2x equals negative 2, divide 2 over, you get x equals negative 1. And so that's my critical number, and in this particular problem, my critical number happens to also be an endpoint. That's not necessarily always going to be true, but it could be. If my critical number is outside my interval, say I had gotten 6, well 6 is outside my interval, so I wouldn't consider it within the context of this problem, because it's not within the interval that I'm concerned with. Okay, but negative 1's an endpoint, so we're going to go ahead and count it. Okay, so now that we have our critical numbers, we have where our relative maxes, relative mins might be, indicating a possible absolute. The other place we're going to have to consider would be the endpoints, right? Because say if this were my graph and it continued up above where my relative maximum is, well, that point up there, that end point, would be the absolute maximum because it's higher than the relative maximum. It's the highest point on that interval. And so when I'm considering my absolute extrema, I think about my critical numbers and my endpoints. And so in this case, the numbers I'll be looking at are 1 and negative 1, and technically negative 1, but we're already considering it. So, okay, and so how do we evaluate then which one's the absolute maximum and which one's the absolute minimum? Okay, well, think about a graph, right? We're talking about the highest point or the lowest point, but we're talking about height on a graph at that point. Okay, well, what coordinate, x or y, gives me height? That would be my y coordinate. Right? X moves me sideways on the graph, y moves me up and down. And so when I want to know what gives me the highest height, I want to know which one's my biggest y, or which one gives me the lowest height, which one's my smallest y. And so I'm going to be plugging these numbers, both of my endpoints, and each of the critical numbers that are inside the interval. In this case, that would just be negative 1. Okay? Each of those critical numbers, we're plugging them all into my f equation, because that'll give me my y coordinate. It will tell me how high or low they go. Okay? When I plug in negative 1, I get negative 1 squared plus 2 times negative 1 minus 4, which is 1 minus 2 minus 4, which is negative 5. And when I plug in 1, I get 1 squared plus 2 times 1 minus 4, which is 1 plus 2 minus 4, which is negative 1. And so which one is my absolute maximum? Which one gives me the highest? Well, my absolute maximum is negative 1, and it's located at x equals 1. And which one's my lowest, my minimum? Well, negative 5 is the lowest one, and it's located at x equals negative 1. If for some reason I had 3 or 4 numbers that I had been plugging in, and so some of them would potentially not be the highest or the lowest, right? I might have plugged in maybe 0 and gotten, I don't know, negative 3. Actually, in this case, I would have gotten negative 4. But say 0 for some reason, obviously doesn't work for this problem, but if 0 for some reason had become a critical number, it's inside the interval, so I would have tested it. I would have plugged it into f and gotten negative 4. Well, negative 4 is neither the highest nor the lowest, and so I would disregard it when it comes to absolute extrema. Right? Absolute extrema, I only care about the highest or the lowest. Okay, so the last one here that I've selected to demonstrate 3.1 is number 42. Approximate absolute extrema, and for this one we're going to be using our calculators. So if you want to go ahead and get that out. F of x equals 4/3 x root 3 minus x, and we're given a closed interval of 0 to 3. And so for calculating it on your calculator, you're going to go to y equals, and you're going to put that equation, that 4/3 x root 3 minus x, into your y equals, like so. 4/3 x root 3 minus x. Okay. And then for my window, I'm only concerned with a set x, right? I only care about this 0 to 3. Now you don't have to set your window at 0 to 3. I like to, just so we can have a clear vision of what we're working with. Also so that we don't get distracted for some reason with numbers that lie outside of my interval. So I'm going to go ahead and make my x min 0, my x max 3, right? And then my y min and y max are currently set at -5 and 5. If for some reason I graph it and I don't get a complete picture from 0 to 3, I can always come back to my window and adjust my y values at that point. So we're going to go ahead and hit graph. You get the following graph. And so then we're asked to find, or to approximate, our absolute extrema. Well, remember, an absolute extrema, we're talking about mins and maxes. An absolute minimum is the lowest point. Well, when I look at this picture here, I notice I have 2 points here that look like they might be the lowest. Right? One here at my left endpoint, which is 0, and one here at my right endpoint, which is 3. And it's possible that they might both be locations of absolute minimum, but we don't want to assume. We do want to calculate it to see which one has the lowest y value, or are they in fact tied. Okay, well, if I know that my endpoints give me my lowest values there, and I know my endpoints are 0 and 3, well, I can find their y's by tracing. On the 84s, that's located right here, next to F4. And on the 89s, it's F3. Okay, and so then we're going to see what happens at x equals 0. When I type in 0, I get that y is 0. And if you hit trace again, and then type in 3 to see what happens at the other endpoint, when I type in 3, I get y is 0. And so in this case, I have 2 absolute mins, right? They're tied. Well, technically I have 1 absolute min, 2 locations where the absolute min occurs. Right? The absolute min is 0, and it's located both at x equals 0 and x equals 3. Okay, so let's go ahead and write that down. My lowest point on my graph, my absolute minimum, is located at 2 places, 0, 0, and 3, 0. Okay. So then the next question is, well, if those are my minimums, where's my maximum? Where's my absolute max? Remember, absolute max is the highest point on the graph. And when I'm looking at my graph, I notice my graph comes up, 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 up to that point, and then back down again. You know, and if we were to guess, we'd probably guess that might be around x equals 2. Okay, but the nice thing about calculators is they can find that for you. All right, so we're looking probably right around x equals 2. On the 84s, to calc your maximum there, you're going to hit second calc. On the 89s, you're going to hit F5. So again, 84s, second calc, 89s, F5. And then number 3 and number 4 here calculate our relative minimums and maximums for us, right? Those valleys and hills. And so if I come down here, I'm trying to find that crest of my hill, right? My relative maximum there. I'm going to go ahead and pick number 4. And it's going to ask me, or it's going to cue me for a couple of pieces of information. On the 89, it's expressed as a lower bound. On the 84, it's expressed as a left bound. They mean the same thing. It just means go left of the point you're trying to find. And so I'm trying to find that point right there. It's around 2. And so I'm going to go ahead and move left of there. So kind of right around here. And it doesn't matter how far left you are, right? My 84, I'm sitting all the way over here. On my 89s, I'm just going to go barely left. By the way, you could type. You do not have to use your arrow for the cursor, but because I'm talking, I'm going to go ahead and use my cursor. Okay, so it doesn't matter how far left you are. Right, 84, I'm really far left. 89, I'm just barely left. But you do have to be to the left of the point you're trying to find. Okay, once you're to the left there, you're going to go ahead and hit enter to kind of lock in that point. And you're telling your calculator, okay, from there to the next point I pick, I want you to find my highest point in that interval. Okay? So the next piece of information it asks you for is your right bound or upper bound, depending on which calculator you have. And again, they mean the same thing. It just means go to the right of that point. Okay, so I'm going to go ahead and plug in at this point. I'm going to select 2.7 because I know that that's close to 3 over here. Okay. Or you can hit your arrow and move your cursor over to the right if you'd like. Okay. Once you're to the right or you've selected a right point, go ahead and enter to lock it in. The 89s is going to calc your maximum for you. 84s, they're going to ask you for a guess. My guess was I thought it was probably around 2. And you can type in the 2 like I've just done, or you can hit your arrow and kind of cursor it over till it's sitting right where you think the maximum might be, and then go ahead and select it. Again, it doesn't have to be perfect. You're just giving your calculator a general area. Again, once your cursor's either over the spot that you're wanting to pick or you've typed in a guess, go ahead and hit enter to lock that in. And now 84s, it'll calculate it for you as well. And so we notice here that we have that maximum, that highest point is at 2, and the maximum is 2.66666666666, right? Which happens to be 8/3. And so that will be my maximum. As far as whether to write your answer as a fraction or a decimal, you can do either one, but if you're going to leave it as a decimal, it has to be accurate to at least 3 decimal places. So you can't put 2.7 or 2.6. It needs to be 2.666 or 2.667 or 8/3. And that's 3.1.